A few hundred years ago, during a time when science was far less advanced, people were often perplexed by everyday phenomena. Ancient civilizations couldn't understand lightning, stars, diseases, magnetism, or even themselves. The world seemed full of mysteries, powerful forces, and strange creatures, all beyond human comprehension. In recent years, however, this confusion has been replaced by a strong confidence. We now assume we understand the world around us, which is a relatively new development in human history. In daily life, you rarely encounter truly mysterious events. You've likely never experienced something completely inexplicable. Lightning, stars, diseases, and magnetism, all of these are now understood to follow natural laws. While these phenomena are complex and awe-inspiring, they are ultimately bound by the laws of physics. In fact, the feeling of being mystified and unable to find an explanation is incredibly valuable. We are willing to pay to experience it again, which is why magic shows are so captivating. Beyond understanding, we've also mastered control over our surroundings. We can routinely fly 400-ton planes across oceans, manipulate the quantum effects of billions of transistors on microchips, and perform surgeries to implant organs into human bodies. When you think about it, we truly live in an age of wonders. Yet, as adept as we are at explaining the major trends and minor details of the physical world, does that mean we know everything? Can our theories explain all things? The answer is, of course, no. As you've seen through this discussion, there are still countless mysteries for humanity to solve. We know almost nothing about dark matter, which fills the universe, or dark energy, an even more powerful force. Our mastery extends only to a tiny corner of the cosmos, while we remain surrounded by an immense ocean of ignorance. We must confront this reality. While we understand much of the world around us, we know almost nothing about the universe itself. How far are we from discovering the ultimate theory, the theory of everything? Does such a theory even exist? Could it unravel all the mysteries of the cosmos? To discuss this, we must delve into what the theory of everything really is. In simple terms, the theory of everything is the most profound and concise mathematical description of space, time, and all matter, energy, and forces in the universe. Let's break it down. This definition includes matter, because the theory must describe everything that constitutes the universe. It also includes forces, as we want to understand not only matter but also how it interacts. Furthermore, it involves space and time, as these two concepts are flexible to some extent and influence matter and forces in the universe while also being affected by them. Most importantly, the theory needs to be incredibly simple and profound because we want it to provide the most fundamental and reasonable description of the universe. It should be as universal as possible and irreducible. In other words, it should use the fewest variables and the fewest unexplained constants and describe the universe at its smallest scale. We seek to find the smallest building blocks of all things and understand the fundamental mechanisms that bind them together. We live in an onion-like universe, composed of many ordinary layers. For example, atoms consist of nuclei made of protons and neutrons, surrounded by electrons. You've likely seen diagrams showing a central circle with smaller circles orbiting around it. This is perhaps the most well-known scientific model and is widely used to symbolize science itself. The introduction of this model was a remarkable achievement. It not only became famous but also signified a deeper understanding that atoms are not the basic units of matter. Humanity realized that matter might be composed of even smaller components. And it didn't stop there. Among these subatomic particles, some are composed of even smaller parts. For instance, protons and neutrons are made up of quarks. Moreover, at this scale, the behavior of forces is entirely different from what we might expect. reality diverges significantly from our imagination. Electrons, protons, and neutrons are not small, solid spheres clustering together. They are quantum particles, defined by waves, governed by uncertainty, and inherently fuzzy. However, these concepts only hold to a certain extent. You might describe an atom as a billiard ball to understand how gas atoms collide within a container. Or you might describe atoms as tightly packed clusters surrounded by electrons to understand the periodic table. Meanwhile, the quantum particle perspective explains various natural phenomena exceptionally well. The key is that in our universe, many theories work without considering the small scale. For instance, you can precisely predict the collective behavior of an object's tiny components even if you don't know the details of each component. You don't even need to know if these components truly exist. Take economics as an example. It can describe the behavior of a group without analyzing the psychology of each individual. The actions of many shoppers and merchants determine macroeconomic trends like pricing, which can be summarized with a few equations. Similarly, physics provides numerous examples where theories remain effective despite gaps in fundamental understanding. Despite not having a complete understanding of the basic building blocks of matter or how gravity functions within quantum mechanics, we can still accurately predict what happens when a monkey jumps into a swimming pool from a rooftop. Newtonian mechanics predicts the monkey's trajectory, fluid dynamics explains the water splashes, and biology details what happens to the monkey upon impact with the water. The universe's theories are layered, much like the onion itself. We had the theory of evolution before understanding DNA. We sent humans to the moon before knowing about particles like the Higgs boson. However, the theory of everything won't explain higher-level phenomena. Instead, it will describe the fundamental building blocks of the universe and their interactions. This makes the concept of a theory of everything nuanced. We might never be 100% certain we've found it. What seems foundational now might have yet another layer beneath it in the cosmic onion. And what if the universe has infinite layers? Would that mean a final theory doesn't exist? These questions challenge us to continue our search. Are there limits to how small distance or matter can get? What about the fundamental forces? Could they all stem from a single, unified origin? These questions are what push us to explore the mysteries of the universe further. The universe might be made of its smallest pixels, and understanding this smallest distance is one of humanity's greatest mysteries. But that's just the beginning of the story. If you think we've reached the edge of knowledge, think again. In the next part, we'll uncover the building blocks of the universe. Are there particles even smaller than electrons and quarks? And what happens when the fundamental forces of nature merge into a single, ultimate theory? Don't miss part 2 of Cosmos Unlocked.